how do I use the equation builder in the Essential Chemistry textbook? The equation builder is available anywhere in the Essential Chemistry book by clicking the equations button in the navigation bar. No matter what equation you're shown, you can always customize it. For example, if I don't want the oxygen term, I first select it and then I delete the term. If I look at the water molecule and I select the oxygen atom there in the molecule, I can add subscripts, remove subscripts. I can reverse the order of the atom by clicking Move Element. And I can add reactants or products. I can also navigate with the previous and next element button, going one atom at a time through the equation. If I want to go to a compound and remove a particular element from the compound, I can select Remove Element rather than deleting the entire term. Let me start with the fresh equation by deleting all of the terms. Starting with a reactant. How about something a little more complicated? What if I do potassium iodide? Here's potassium in period 4. Once I select it, the flag turns pink and I can add the element. And I have to use the crisscross rules that I know to create the compound potassium iodide. I have to know that potassium has a charge of +1, being in group 1. And iodine, which is in period 5, I have to click the periods 5 through 7 button to get to iodide. Select it and add the element. And again, if I accidentally use the wrong order, I can always move elements. Next, I want to combine the potassium iodide with lead nitrate. So if I want lead, I select lead, and if I add the element, that would place the lead in the potassium iodide compound, which I don't want. So rather than, again, I don't need to delete the entire term, I can just remove the element. And now that I want a different product, I have to add reactant. I would have to add a reactant to get the plus sign to show up to add my next compound. Now, the lead to nitrate, I am going to begin with lead. And this is lead to nitrate, so I have to, in my head, know that I've got a +2 charge on the lead. Nitrate is not an element on the periodic table. It is a polyatomic ion. You won't find nitrate here. Sure, you find nitrogen and oxygen, but the compound is lead to nitrate. Therefore, you go to the compounds and ions section and select the nitrate ion and add it. Notice how it adds an O3. It does not do any crisscrossing for you. You have to do that on your own. So you would know that nitrate having a charge of -1, lead having the charge of +2, you would have to crisscross that 2 down to the nitrate. And once you do that, I've got the nitrate selected. That's why the 2 went to it. Once you crisscross, once you add a subscript to the nitrate, it automatically adds the parentheses around that ion. So this helps teach and learn about how to work with subscripts on polyatomic ions as opposed to elements. So if I were to add a subscript to lead, no parentheses are needed because it is not a polyatomic ion. Next, moving on, I have a product, potassium nitrate. So I need to go back to periods 1 through 4 to get the potassium. And again, compounds and ions for nitrate, and understanding that the charges cancel, the compound is now correct. I'm going to add a product, lead to iodide. Here's my lead 2 and iodide, which crisscrosses to get a subscript of 2. And the equation builder does not tell you whether you're correct or incorrect, but it does allow you to move on and try and balance your reaction. And it shows the visualization of the law of conservation of mass. So you can see that reactants and products have equal amounts of potassium, but there's more iodine in the products than in the reactants. So when I go to the reactants, I can find the term that has the iodine, and I can change the coefficient. And that is the only choice I have here, is to change the coefficient. I can't change subscripts, so this helps me learn. When I'm balancing equations, I'm not changing subscripts. All I'm doing is changing coefficients, the number in front of the term. So I've got the iodine balanced, but I do not have equal amounts of nitrogen or oxygen in the products. So I can go over to the products and start with the nitrogen term, change its coefficient, and now I can see it's balanced by adding the coefficient of 2. So another great way to use this tool for teaching and learning is to visualize the law of conservation of matter. And once you've got a balanced equation, suddenly you have access to the stoichiometry and show me how buttons, which were grayed out before because you must have a balanced equation before you can do stoichiometry. Next, let's do stoichiometry. So once you've determined the balanced equation, it will apply the mole proportion 2, 1, 2, 1, or whatever the order is in your equation down below in the same order of your equation. So potassium iodide, there are 2 moles in proportion to 1 mole of lead nitrate. The top row that is gray, those are the formula masses. The middle is the mole ratio. And the bottom is, if you had 2 moles of potassium iodide, that mass would be about 332 grams based on the formula mass. And that is calculated out for each term. Now this is also customizable. I cannot click the formula mass because that's a fixed value. But if I want to say, hey, if I had just 0.1 moles of lead-2 nitrate, how would that change the masses of all the terms if I were to react this amount of moles of that compound? Now, once I enter that, now I see I still have that same proportion, 2 to 1 to 2 to 1, applied across the moles, and I can see the effect on how does that mass change. It's still the same proportions, but now how much mass would I need? Or how much mass of potassium iodide would I need to react with the moles of lead-2 nitrate that I have, and how much products could I get? So rather than seeing this as I can cheat with this tool, it is I've learned how to balance equations, I've learned how to do formula masses, and now I can check my answers. Or I can learn more about how proportions work. So if I were to apply 3 moles of potassium iodide, how does that change the values in all of the moles and masses required for this reaction? And we can see that same proportion. When we reduce this, we get 2 to 1 to 2 to 1. And we can see the effect on the masses required or products being made with those amounts. Now, next, you could also change the grams as well. So let's say that you got 5 grams of potassium nitrate, and how would that, if you were to do the reaction, what are the outcomes? Okay, now you can see the, again, same proportion of moles applied and the matching masses you would need when those moles are applied to each of the compounds. So how did we get to these numbers? That's what the Show Me How button does. Now, it starts off with the first term, and you can see the color coding. It's showing how to convert using the formula mass and moles. How did we get this value, or how do you get from this value to the moles in one term at a time? If you were to click next, it just goes to the next term through the moles first, and then through the grams. So if you're curious about how do we get the 1060 grams from 2.3 moles of lead-2 iodide, this is what the Show Me How does. Within a term, how do we calculate these individual values? So it really emphasizes the importance of the mole as the bridge, the way to get from one term to another in stoichiometry. And you might think you might be able to cheat with this tool, but you can't, because you change a moles term, it's always one directional, always goes through all the moles first, then it goes to the grams. So it does not do a direct line calculation. It just goes through each of the terms one at a time. Another way that you might encounter the chemistry equation builder is if you're reading in the textbook and you come across a balanced reaction. Sometimes the interactive simulations, when hovered over, will show a balanced reaction. That means when you click it, it will bring up the exact equation balanced in the context that it is shown on the page that you're reading. So this is the methane with the oxygen reaction. And then below that, you might bring up a different simulation, whether it's the molecule interactive, or the chemistry equation builder, or a different simulation.